Hello, welcome again, lovely year sevens. You're building some really good foundation in maths. So share my screen. So welcome to your third lesson of block one in sequence. In your previous lesson, you learned to predict and to check using diagrams sequences. So you were able to predict the next terms of sequence, and then you were able to draw the diagrams to check whether you were right or wrong. Now, this helped you to stick to the rules, being able to describe the sequence using the rules, what you think was generating the next term in the sequence. Today, we're going to learn about representing sequences in tabular and graphical forms. But before we do some learning, I would like you to do some retrieval practice to help you think about and to help you recall what you learned in your previous lesson. I'll give you 3 minutes to get this done. I'll be generous, I'll make it 4. I think this involves some work actually. Okay, you have 2 minutes left. Okay, it's time to check our answers. So the first question is you should describe, is asking you to describe the sequence. Remember from our very first lesson, to describe a sequence, you need to say what is producing the next term. So what is really going on to get from one term to the next, from one term to the next. So when we look at this sequence, we'll see that, okay, we see that the three hexagons are added each time. So here we have four hexagons. You have one, two, three, four. Here you have seven. Okay, so we're adding three hexagons every time. Okay, and then we're told to draw the fourth term in the sequence. The fourth term in the sequence obviously will be this hexagon here. Now, don't forget what we learned from our very first lesson. You know that the first one is called the first term, and we always start counting from the left. Sorry. We always start counting from the left. Don't forget about that. So this is the first term. Okay. That's the second term. All right. We always start counting from the left, and that's the third term. All right. So the fourth term, remember what we want, the skill we learned from our very first lesson. It's good to count, especially the first two or the first three terms of the sequence, and write the number out. So if we had written the numbers out, we'll clearly see that that's 4, that's 7, okay, and then that's 10, okay, because we're adding three hexagons every time. So you can clearly see that you're adding three every time, so you know that's 10. So if you work with the numbers, it will be easy for you to know that, okay, I need to draw 13 hexagons instead of spending time counting every time. Okay. And then the next one, we can use the same skill. Yeah. So this one here, we can see that to describe the sequence, we just need to observe how the sequence is changing from one term to the next term. And then we can clearly see that the number of circles added each time increases by 2. Okay. So if we write out the numbers, it will be easier to do it. So if we had written 1, you say, okay, I can see that there are 5 here. Then I can see that this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So you see that what the number of circles you add in every time is increasing by 2, increases by 2. So here we added 4, which means here we'll add 6, which means the next one you say, okay, I need to add 8. So it will be easier counting first, writing the numbers out. It will be easier for you to now work from the numbers to get how many circles you need to draw. So it's a very important skill. Make sure you don't forget about this skill. Okay. Then 2B is asking you how many circles are needed for the fifth term. So clearly you're going to need to, use this skill I told you just now to know that, okay, I'm going to need 29 circles. All right. So if you were asked to just state the number, you wouldn't even need to draw it out. You can just state the number by using this skill here. Okay, let's move on. So let's drop this off. All right. Okay. Now, if I show you this sequence, you can clearly see that we have 3 triangles, 5 triangles, and then 7 triangles. So remember, the title of our lesson is to be able to represent sequences in tabular form. So we'll put our information in a table. You will see one in a minute. And then we'll make progress to put that same information in a graph. Okay. It's a very important skill that you will need in future, in your future study, both year 7 and year 8. So it's important we know how to do it. So the first thing we're doing is to actually put it in the table. Now, Before we fill this table, I want you to always have in your head that this thing I call term here is actually value. Okay, I want you to have in your head that we're going to call this term value. Okay, every time we're going to be calling it term value. So position one, which is term one, so your position is the same. The position on this table is the same as the term. So first term is position one, second term is position two, third term is position three. And then these numbers here is the value of the terms. So that's what we're going to do now. So if we do that, you would see that you have this table. So we have succeeded in learning our first skill for this lesson, which is to be able to put our sequences in a tabular form. Okay. Okay. I now want you to have a go at questions 1 and 2. You should be able to do this in 3 minutes. This is a very quick task. You should be able to do it in 3 minutes, even less than 3 minutes, but I'll be generous. I'll give you 3 minutes. Okay, I'm going to cut the time short. I'll make it 2 minutes because this one is an easy one. Okay, let's look at our answers. So this is really straightforward, right? So you're asked to match them. Yeah, so remember what we said. Position 1 refers to term 1 refers to position 1, term 2 position 2, term 3 position 3. And then the numbers that we put in this part called term is actually the term value. So actually counting how many items you have in that term. Okay. All right. So here are the answers. You can mark your work. Okay. Let's move on. Now, remember, the title of our lesson is you need to be able to put sequence in a tabular form, which is this one here, and also in a graphical form. All right. Those are the two skills we really need to learn in this lesson. Now, if we want to put this same sequence in a graphical form, we can have something like this. So if you have, most students have a book that they use that is already in a grid form. So take note of what this scale, so we call this scale, yeah? So take note of what it is, because here one square on this side, one square represents 1 unit, one square represents 1 unit, one square represents 1 unit. On this side for the position, one square represents 1 unit. So this is a very easy graph to plot. So the way we do it, we simply just say, okay, when we are at position 1, it matches with when the term value. Don't forget, I want us to add that word there. Term value is 3. Okay, so if we were to, because this skill is important, there's a lesson you're going to do where you're going to be plotting graphs. Okay, so yeah, when it's in position 1, the value is 3. When it's in position 5, position 2, the value is 5. Okay, when it's in position 2, the value is 5. Yeah, when it's in position 3, the value is 7. When it's in position 3, the value is 7. Okay, so your graph will now look like this. Okay, so you've succeeded in putting the sequence in a tabular, in a graphical form. Okay, here is this one. If we look, we'll see that that's position 1. Position 1, the number is 1. The value, term value is 1. So let me write term value. You should remember that. Okay, the term value is 1. So term value. Position 2, the term value will be 3, because you can see there are 3 items there. So term value will be 3. All right. Position 3, the term value will be 6. You can see there are 6 items there. And position 4, the term value will be 10. You can see there are 10 circles there, 10 items there. Could be anything. Could be squares, could be, I don't know. Now, the next thing is for us to plot the graph. So let me rub this off so that we have some space to do what we need to do. All right. So to plot the graph, I guess you'll be thinking you already know what we need to do. So when it's in position 2, when it's in position 1, we can clearly see that the value is 1. Now take note, you see for the position here, the scale is different when you compare it to the value of the term. Yeah, the scale here. All right, so here 1 unit, 1 square represents 1 unit. So square, 1 square, 1 unit, 1 square, 1 unit. But here 1 square represents 2 units. Yeah, so notice that 1 square represents 2 units. So which means that when it's in position 1, our 1 here will be it will be halfway before you get to 2. So it will look like this. Okay, so just a minute. Yeah, it will look like this. So when it's in position 1, it has to be halfway, because in the value of term on that side of the graph, okay, on that side of the graph, you can clearly see that when it's in 1, it should be here, because from here to here is 2. Yeah, and you can see when it is 2, here it should be 3. So it has to be halfway between 4 and 2. So that should be 3 and that should be 1. But we don't need to write it, because we already know that in the value of on that side of value of term, each square represents 2 units. So halfway has to be 1 unit. Okay, so that's how you go about it. And then if you do that, your graph will look like this. Okay, to look like this. Right. Now I want you to compare the two graphs because look at the first one we did. Okay. And then look at the second one we did. What do you notice? What's the same? What's different? There's something interesting about these graphs. I want you to have a think. I'll give you about 5 seconds. Have a think. What's the same? What's different? Okay. You can see that this one, the line is straight. Yeah. And this one, the line is curved. Okay. Now take note, that's not the main thing because there's something we're getting at here about how to be able to differentiate. Now I'm going to let the cat out of the bag anyway. I'll say how to differentiate, how to tell when a sequence is actually linear and when it's not. Okay. There's something you will notice. There's something we're getting at. But when we plot the graph, it will show really clearly that, oh, this is linear. So it means straight. And then this is non-linear. It's not straight. The line is not straight when we're plotting on the graph. But how do we notice it when we check the numbers? Yeah, I want you to have that question in your mind. How do we notice it when we look at a sequence? How do we say, oh, looking at the numbers, this is a linear sequence or this is not a linear sequence? Okay. So you can see here, notice this. Yeah. So I want you to have this important point in your head. It's so important, you shouldn't forget it. A linear sequence is when the numbers are changing by the same amount every time. So this here is linear. So anytime you're working on a sequence and you notice that the numbers are changing by the same amount every time, you just know that that's a linear sequence. And see here, yeah, you can see the numbers are not changing by the same amount every time. Now, I want to tell you a special word we call this because this will serve you even till year 11 or even going beyond that if you happen to study maths at A level. This here is called constant difference. Constant difference. Sorry. Constant difference. Let me just write it here. Extend it there. Yeah. So I want you to have that word really fixed in your mind. When the sequence is changing by the same amount every time, well, let's use the correct word now. If a sequence has a constant difference, it is a linear sequence. I'll repeat. When a sequence has a constant difference, it is a linear sequence. So you've learned some really new words in this lesson. I hope you don't forget. Okay. And then you can clearly see that this is a non-linear sequence because it does not have a constant difference. Okay. Let's move on. Okay. Now I want you to have a go at the rest of the questions. We've done some really important learning. So some of the things we have learned is number one, you can put a sequence in a tabular form. You can also put that same sequence in a graphical form. And by putting in a graphical form, you'll notice that if the sequence is linear, the sequence will have a nice straight line when you plot it. Yeah, when you join all the points. If it's a non-linear sequence, the graph will have a curved line. And how to notice it in terms of numbers, let's say you didn't plot it, you're just working with the numbers of the sequence. You will notice that we learned a new word, take note, constant difference. So the number is changing by the same amount every time. And then if it's non-linear, it's not going to have a constant difference. So the amount by which the sequence is changing will be different every time. Okay. All right. So here is the first question I want you to have a go at. I would like you to do this in 3 minutes. You should be able to do this in 3 minutes. Okay, we have about 1 minute left before we check our answers. Okay, let's check our answers. So here, the question you were being asked to describe each of the representations. Yeah, by now you know what it means to describe. You need to say how many lines was used to make this the diagram of the first term, then say this one, and then you can then say how much the sequence is changing every time. Okay. Now you can see, just looking at the graph, you can see that it's a linear sequence. You can see you can join that with a straight line. Okay. And then this one, remember, this means term value. So position 1 has value 1 because there's only one square. Position 2 is going to have value 4 because there are 4 squares, right? And so on and so forth. You can even use the graph to complete it because you can trace and say, okay, what number does this match? Yeah, let's say for the third term, you didn't know. So you can say, okay, that's 3. Okay. If it's between 10 and 8, then that has to be 9. Yeah, you can clearly see that there are 9 squares here. So you could use the diagram to complete the table. You could also use the graph to complete the table. Okay. So here are the answers. You can mark your work now. So for the first one, there are 4 sticks, there are 7 sticks, and there are 10 sticks, right? The sticks And then the table tells us that the first term is 4, the second term is 7, and the third term is 10. So by now you know how to describe sequences. And then the graph tells us that the same information as the table. So remember the title of our lesson. You're going to be able to represent sequence in a tabular form, this is a tabular form, and in a graphical form, which is to, plot the graph from the table. All right. And then B, you were being asked, for B, you were being asked what is the same about each of the representation. Well, it represents the same sequence. Yeah. Each representation shows the same sequence. And then for C, you were being asked, what do you notice about the points on the graph and why might this be happening? Okay, what we notice is the points join together to make a straight line segment. This is because they represent a linear sequence. So remember what we said, a linear sequence has a constant difference. See that word? Very important. Don't forget that. Constant difference between each term. And then for question 4, you could just use either the graph or the diagrams to complete the table, right? Really straightforward exercise. And you can see for B, you were being asked, um, why don't the points on the graph make a straight line? Again, remember what we said. It's because it does not have a constant difference, right? Very important. Okay, have a go at the rest of the questions. So this time, question 5. So here they're asking you which sequences will have points that form a straight line if plotted on a graph. Don't forget about that skill we learned. You could just count, write the numbers, and check whether we have a constant difference. Keyword. Okay, I'll give you 2 minutes to get this done. You should be able to do this in 2 minutes, really quick. Okay, 1 minute left. I'm sure you're working hard. And don't forget to explain your reasoning. So it's at the bottom of the page. It says explain your reasoning. Okay, it's time to check our answers. So here are our answers, right? So you can clearly see that this one will give us a linear sequence. So if we were to count, we have 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Uh, sorry, let's check again. 1, 2, 3, 4. Yeah, 8. This one we have 1, 2, 3. 1, 2, 3. That's 6. Plus 4. That's 10. So let's check this one. We have 1, 2, 3, 4. 1, 2, 3, 4. Then we have 4 there. That's 12. So we're going up by the same amount every time. This one is the same thing. We're going up by the same amount every time. Yeah. So these sequences are linear because in each case there is a constant difference. Yeah. So the things we've learned in this lesson so far are: number one, you can take a sequence and put it in a tabular form. And you can take a sequence and also put that same sequence in a graphical form. And in the graphical form, if it's a linear sequence, you see a nice straight line. You'll be able to join the point with a straight line. But if it's a non-linear sequence, you see that the line is curved, right? And then if you check in the numbers, you will see that for a linear sequence, you will have a constant difference. But for a non-linear sequence, you don't have a constant difference. So the numbers that you get when you check from how you get from one term in the sequence to the next term won't be constant. Yeah, it won't be the same. That's what it means. Okay, that brings us to the end of our lesson. Until next time, take care.